Okay, so I've opened up glutamate, the glutamate.hin file in JMOL. And our first task when we're looking to find the chirality of a molecule is to identify any chiral centers. So let's just move the molecule around so you can see each of the carbons. And I hope you'll spot very quickly that there's only one chiral center in this molecule, only one carbon with 4 different substituents. It is, of course, this one here. So, once we've found the chiral center or chiral centers, our next job is to identify the priority of the substituents. Now we can find the lowest priority substituent on this molecule quite easily. It's obviously the hydrogen here. Remember, Cahn-Ingold-Prelog prioritizes molecules on the basis of their atomic number, or the atomic number of substituents around a chiral center. The highest priority substituent is also easy to find. That's the nitrogen. Nitrogen has an atomic number of 7, carbon 6. Hydrogen is 1, of course. The final 2 substituents are a little bit more tricky. We've got 2 carbons here. Now they're obviously different groups, so we've definitely got a chiral center, but which one is the higher priority? Well, again, you've got to remember that we're dealing with atomic number. Now the way that the Cahn-Ingold-Prelog system tells you to deal with this kind of situation is that you move along the chain of atoms, always moving to the highest atomic number atom available. And when you find a difference, then that's where you make your decision about priority. So with this carbon here, if we move to the next highest atomic number atom, it's another carbon. With this one, if we move to the atom which is bonded to it, which has the highest atomic number, it's an oxygen. Now oxygen has an atomic number of 8, obviously higher than carbon, which is 6. So that means that this group here, even though it's got a smaller molecular mass than the one over here, takes priority. So our order of priority is the amino group, this carboxylic acid group, and then the other substituent with the carboxylic acid on the chain. So, we found our chiral center, we prioritize the substituents. Our next task is to rotate the molecule round so that the lowest priority substituent faces away from us. Now, that's quite easy to do on a molecular modeling program. It's one of the reasons why I'm showing you here. Doing it mentally is a little bit more challenging, but you'll learn how to do that with a bit of practice. So let's rotate our molecule round. There we go. Now we've got the hydrogen hidden facing into the screen, and you can see that the substituents, 3 substituents, form a triangle centered on the chiral center. Highest priority is this amino group here, followed by the carboxylic acid group, followed by the chain with the carboxylic acid group at the end. That's in an anti-clockwise direction. So this molecule is clearly in the S or sinister configuration. And that's all there is to it. The only difficult thing here was to distinguish between these 2 groups and to remember that you're dealing with atomic number, not atomic mass or molecular mass.